Welcome to this video, which is about how to solve quadratic inequality. At first, let's take one quadratic inequality in one variable, that is x square minus 4x plus 3 greater than or equal to 0. A quadratic inequality is just like a quadratic equation, except in place of an equal sign, there is an inequality sign. To solve this type of inequality, at first, write it in factor form. That is, represent as a multiplication of two factors, that is x minus 1 into x minus 3 greater than or equal to 0. Now, find the solution considering the inequality as equation. Since the equation is quadratic, so we'll get two solutions, that is x equal to 1 and x equal to 3. Then, using number line, we can solve this inequality very easily. If we plot this solution x equal to 1 and x equal to 3 in number line, we get three parts of number line. That is, these two values split the whole number line into three parts. The first part, the second part, and the third part. Now, we have to test the validity of solution using any value from each part of this number line. That is, from first part, let's take x equal to minus 2. Then, substitute this value in place of x in the inequality to check whether the inequality is satisfied or not. That is, x minus 1 into x minus 3 greater than or equal to 0. In place of x, we will substitute the value x equal to minus 2. In this case, we will get 15 greater than or equal to 0. So, for the value x equal to minus 2, the inequality is satisfied. So, this part is valid for the solution. So, we can say with this value or any value within this range minus infinity to 1, the inequality will be satisfied. So, this part of number line is valid for the solution. Similarly, from the second part, let's take x equal to 2. Then substitute the value of x in the inequality, that is x minus 1 and x minus 3 greater than or equal to 0, which gives minus 1 greater than or equal to 0. So with this value, the inequality is not satisfied. So we can say with this value x equal to 2 or any value within 1 to 3, this inequality is not satisfied. So this part of number line is not valid for the solution of this inequality. Finally, let's take any value from the third part of number line, that is x equal to 4, and substitute the value of x equal to 4 in the inequality, we will get 3 greater than or equal to 0. So we can say with this value x equal to 4 or any value from this part of number line will satisfy the inequality. So this part 3 to infinity is valid for the solution of inequality. Now write the solution. So here we have two parts valid for the solution and one invalid part for the solution. So we can write the solution is minus infinity to 1 and 3 to infinity. Here this value 1 and 3 is included in the solution. That's why this type of bracket is used here. So minus infinity to 1 and 3 to infinity. To join this one, we use the union sign. So the solution is minus infinity to 1 union 3 to infinity. So this is our solution of this inequality. Alternative way of writing this solution, that is, we can write this solution in another way. That is minus infinity to plus infinity, that is the whole real number minus 1 to 3. If we subtract the value from 1 to 3, except the value 1 and 3 from the real number, then we will get the similar solution like this one. That is, we can write this solution as minus infinity to plus infinity minus 1 to 3, where this 1 and 3 is excluded. Or we can write that is x belongs to real number and x is less than or equal 1 or x is greater than or equal to 3. Let's solve another inequality, that is x square minus 4x plus 3 less than or equal to 0. Similar as previous, first write it in factor form, that is x minus 1 into x minus 3 less than or equal to 0. Then considering as equation, find the solution of the equation, that is x minus 1, x minus 3 equal to 0, that is x equal to 1 and x equal to 3. Then use the number line, and in number line just plot this solution x equal to 1 and x equal to 3. With this x equal to 1 and 3, this number line is split into three parts, that is minus infinity to 1 and 3 to plus infinity and 1 to 3. First part, this one is second part, this one is third part. There is minus infinity to 1, 1 to 3 and 3 to infinity. Now test whether the inequality is satisfied, that is which part of number line is valid for the solution for this inequality. For this, first take the value x equal to minus 2 from the first part, that is minus infinity to 1, and substitute this value in the inequality. We get 15 less than or equal to 0. So for this value or any value from within this range, the inequality is not satisfied. So this part is not valid for the solution. Take the value x equal to 2 from the range 1 to 3 and substitute this value in inequality. We will get minus 1 less than or equal to 0. So we can say for this value x equal to 2 or any value from 1 to 3, the inequality is satisfied. So this part is valid for the solution. Similarly, for the third part, if we take the value x equal to 4 and substitute this value in inequality, we will get the value 3 less than or equal to 0. For this value, the inequality is not satisfied, so this part is not valid for the solution. So we can write the solution as, so for the solution we have two invalid part and one valid part, and the valid part is 1, 2, 3. So we can write the solution as start bracket 1, 2, 3. The meaning of this bracket is the boundary value is included. So the solution of this inequality is starting from 1 to the number 3, where 1 and 3 both are included. So this is our solution. We can write it in another way, that is alternative way of writing this solution, that is x belongs to R, 1 is less than or equal to x and less than or equal to 3, that is x is greater than 1 and for less than 3. Now let's solve another type of quadratic inequality where this sign is greater than or just less than. There is no equal sign here. So x square minus 4x plus 3 greater than 0. Just write the factor form x minus 1 into x minus 3 greater than or equal to 0 and find the solution. Considering as equation, we get x equal to 1 and x equal to 3. Then use the number line to solve this inequality. First, plot this value x equal to 1 and x equal to 3 in number line. But here, for this type of sign, that is only greater than or less than, we cannot take this value, that is x equal to 1 and x equal to 3 is not included in this part, that is from minus infinity to 1 except 1. This one is our first part. And from 3 to plus infinity, but excluding 3, this one is the second part. And the third part is 1 to 3, but this 1 and 3 in this case also excluding. So we get this three part of number line. So we have to test where the inequality is satisfied. That is from the first part, if we take x equal to minus 2 and substitute this value in inequality, we get 15 greater than 0. So here with this x equal to minus 2, the inequality is satisfied. So we can say this part is valid. For x equal to 2, the inequality is not satisfied. So this part is not valid for the solution. Similarly, for the third part, that is x equal to 4, in this case the inequality is, that is for x equal to 4, the inequality is satisfied. So this part is valid for the solution. So now we are going to write the solution. That is, we have two valid part and one invalid part as previous. Minus infinity to 1 where 1 is excluded and 3 to infinity where 3 is excluded. That's why we use this type of bracket. And here the union sign. So the solution of this inequality is minus infinity to 1 union 3 to infinity. Just this 1 and 3, these two value is excluded. So this is our solution. This solution, that is minus infinity to 1 union 3 to infinity, we can write it in another way. that is the alternative way of writing is minus infinity to infinity and minus 1 to 3. That is, if we subtract the value 1 to 3 including 1 and 3 from the minus infinity to plus infinity, this one is also to represent this solution, that is minus infinity to 1 union 3 to infinity, where 1 and 3 is excluded. And another way of writing is x belongs to real number, x is less than 1 and x is greater than 3. Now let's see another type of quadratic inequality, that is x square minus 4x plus 4 greater than or equal 0. If we write it in factor form, we can write x minus 2 whole square is greater than 0. And if we find the solution considering as equation, we will get just one solution, that is x equal to 2. So this one is a special case. For this type of quadratic equation, we get two equal solutions. That is, we just have one solution, that is x equal to 2. With this x equal to 2, the number line is split into two parts, that is minus infinity to 2 and 2 to plus infinity, where this 2 is not included because of this greater than sign. If the value is greater than or equal, in that case we can take this x equal to 2. But here just greater than sign, for the greater than or less than sign, where the equal sign is absent, in that case we have to exclude this value, that is x equal to 2. So here we get two parts, that is minus infinity to 2 and 2 to infinity. In the both the case 2 is excluded. So if we take any value from this minus infinity to 2 and substitute the value in this inequality will be satisfied, since this one is for this square. That is, we know for the negative value and the positive value, if there is a square, then the value must be positive. So from this minus infinity to 2 except 2, this inequality is satisfied, and from this 2 to infinity except 2, this inequality is also satisfied. So we can write the solution as minus infinity to 2 union 2 to infinity, where just exclude this value 2. So for this type of inequality, where in the left side can be written as perfect square and here just only less than sign, in that case we just avoid this value, that is minus infinity to 2 union 2 to infinity. This is our solution. This solution we can write it in another way, that is minus infinity to infinity and just subtract this value, that is 2. In this case we just subtract this 2 from this minus infinity to plus infinity. So this is our solution. We can write this solution also this one.